This mirror was built for an agency that looks down at Earth. Now NASA is turning it the other way. The mirror at the center of the Nancy Grace Roman Space Telescope came from the National Reconnaissance Office, the agency responsible for America's reconnaissance satellites. It is almost 8 feet across, the same diameter as Hubble's main mirror. But Roman is not a recycled spy satellite, and it is not simply Hubble with a new camera. NASA used transferred optical hardware as the starting point for something different, a telescope built to stop looking at the universe through a keyhole. NASA currently plans to launch Roman on August 30th, 2026, aboard a Falcon Heavy. The observatory is already at Kennedy Space Center for final preparations after its schedule moved months earlier than expected. Hubble gave us the close-ups. Webb looks even deeper into small pieces of the sky. Roman's job is to connect those pieces, to make enormous, sharp infrared maps, then return to them again and again. That difference sounds simple. It changes what astronomers can discover, how quickly they can discover it, and even where the science has to happen. NASA was already studying a wide-field infrared mission when the Reconnaissance Office transferred 2 unused telescope assemblies in 2012. One offered a 2.4-meter primary mirror, roughly twice the diameter in NASA's earlier concept. That did not hand NASA a finished spacecraft. Roman still needed new science instruments, a spacecraft bus, solar panels, communications, thermal control, software, and an optical system adapted for a completely different direction and purpose. The inherited mirror saved a difficult first step, but it also forced a larger question. If NASA now had a Hubble-size eye, what should it do that Hubble could not? The answer was field of view. Roman's main tool is the wide-field instrument, 18 detectors working together as a 288-megapixel infrared camera. The mirror collects the light, but the camera and optical design decide how much sky reaches the final image. The result should have near-infrared sharpness comparable to Hubble across a field at least 100 times larger. In one official comparison, Hubble needed 432 separate pointings to cover a region of the Andromeda Galaxy that Roman can cover in 2. This is not 100 times more detail. It is 100 times more context in a single look. Imagine trying to understand a city from one perfect photograph of a single intersection. You might see every window, but you would miss the traffic pattern. Astronomy has the same problem. Dark matter cannot be photographed directly. Astronomers infer it from the way huge numbers of galaxies are distorted and clustered. Dark energy reveals itself through changes across cosmic distance and time. Rare explosions and feeding black holes are easier to catch when the telescope watches more sky more often. Roman is designed to survey large regions up to 1,000 times faster than Hubble. Its advantage is not only what fits inside one frame, it is how many frames can be connected into a statistical picture of the universe. The same survey logic applies closer to home. Most confirmed exoplanets are easier to find when they orbit relatively near their stars. Roman will also use gravitational microlensing, watching what happens when the gravity of a foreground star briefly magnifies the light from a more distant one. A planet around the foreground star can add a tiny extra signal. The alignment does not last, and it may never repeat. To catch enough of these events, astronomers need a sharp view of a crowded star field, monitored continuously and at enormous scale. Roman will not take a portrait of every planet it detects. It is designed to build a census, including worlds on wide orbits that other methods often miss. But once Roman can see this much sky, the telescope creates a second problem: the data. NASA expects roughly 1.4 terabytes of raw science data to come down every day. Over the 5-year primary mission, the processed archive is expected to reach about 20 petabytes. NASA says 1 month of Roman data could contain roughly twice the volume Hubble produced over its first 30 years. Downloading all of that to one researcher's computer is not a realistic plan. So NASA and its partners built the Roman Research Nexus, a cloud environment where scientists can bring their analysis to the data instead of moving the entire archive to themselves. Roman's data policy may be as consequential as its camera. The mission says science data will have no proprietary period. Once observations are processed, multiple teams can work on them at the same time. A survey made to study dark energy could also contain an unexpected supernova, a small object in our own solar system, or a galaxy no proposal originally targeted. That changes the observatory from a machine that answers one team's question into infrastructure that can produce questions nobody had written down yet. The bottleneck moves. First it was collecting enough sky. Now it becomes finding the important signal inside a public ocean of pixels. This does not make Roman a replacement for Hubble or Webb. Webb's much larger mirror and specialized instruments are built to examine fainter targets in extraordinary depth. Hubble still observes ultraviolet and visible light that Roman does not cover in the same way. Roman can find the neighborhood, the pattern, or the event. Other observatories can move in for the close-up. Roman also carries a coronagraph intended to block a star's glare and test technology for imaging planets. But it is a technology demonstration, not a promise that Roman will photograph another Earth. The honest comparison is not which telescope wins, it is what becomes possible when they work as a system. So the strange origin story matters for more than the headline. An optical system transferred from an agency built to study Earth helped push NASA toward a telescope designed to study the universe at scale. Around it, the team built a new camera, a new spacecraft, and a new way for scientists to share the result. If the launch and commissioning go as planned, Roman will not give us only the next iconic space picture. It will give us the map that tells every other telescope where to look next. The spy agency mirror is the hook. The real story is the change from seeing objects to seeing patterns.